Okay, now we're going to begin talking about congruent triangles. So this is card 50. So first I just want to remind us exactly what congruent means. So objects that are exactly, okay, not close to, exactly the same size and shape are congruent. Okay, which is this symbol that you should know by now. Alright. The next thing I'd like to talk about on this card is corresponding. When triangles are congruent, comma, the sides and angles that coincide, in other words, are in the same positions, are called corresponding parts. When two triangles are congruent, when two triangles are congruent, comma, there are 6 facts that are true about the triangles. Okay. The triangles have 3 sets of congruent sides, which means they're equal length, and the triangles have 3 sets of congruent angles. Let's just fix this over here. Let's leave that as length. The sides would be length and the angles will say equal measure. Okay? So, let's draw a picture of this. Okay. So I'm going to draw two triangles. All right. The first side I'm going to make 2 inches long on this triangle. And then I'm going to make the next side 1 inch long. And the third side's going to be a little more than 1.5 inches long. Okay. Now I'm going to draw the same triangle, but I'm just going to orient it a little differently. So 2 inches. And then 1 inch. And then this is a little more than 1.5 inches. So these two triangles are congruent, even though I've moved one of them around a little bit, and I did that on purpose. All right. So if this was triangle A, B, C, and this is triangle D, well, I should put that straight up like this: D, E, F. Okay. That has 3 sets of congruent sides. So if in this triangle AB, now we have to look for the corresponding side in the other triangle. And this is the shortest side here. So the shortest side over here is DE. So this would be congruent to DE. The second longest side, or shortest side, is BC. And that's the same side as FE. And the longest side is AC, and that corresponds to DF. Okay? Now, angle C, well, let's actually start with angle A. Angle A corresponds to angle D. They're congruent. And angle B corresponds to angle E. They're congruent. And then angle C corresponds to angle F. Okay? So we've marked all of the corresponding parts of the triangles. Now, let's write down our statements here. AB, segment AB is congruent to segment DE, and segment BC is congruent to segment EF. Okay, and segment AC is congruent to segment DF. And also, angle A is congruent to angle D. Angle B is congruent to angle E. And finally, angle C is congruent to angle F. So there's our 6 pieces of information about congruent triangles. All the sides and all the angles are congruent in congruent triangles. Okay? Let me see if there's anything else I want to add. Okay, that is good enough for the first card on congruent triangles. Okay, so let's put that aside. And let's take out the next card. And we'll call this card 51. Okay. Now let's see. To prove two triangles are congruent, comma, we do not need to show all three sides and all three angles are congruent. Okay. Certain combinations are sufficient to prove that triangles are congruent. Okay. There are 5 methods for proving triangles are congruent. Okay. And here they are. Number 1 is SSS, which stands for side, side, side. And we'll talk more about that later. Number 2 is SAS, and that would be side, angle, side. Number 3 is ASA. Angle, side, angle. Number 4 is AAS. Angle, angle, side. And number 5 is HL, which stands for hypotenuse, leg. And this one is for right triangles only. Okay? Now, let's see here. that is going to be enough for that card, okay? There's nothing on the back of that card. So let's do the next card. That was card 51, so now we're going to do card 52, and we're going to start breaking down these separate congruence techniques. If three sides, this is SSS now. If three sides of one triangle, if three sides of a triangle are congruent, to three sides of another triangle, the triangles are congruent, comma, so then the triangles are congruent. And this is S, S, S. So now let's go on the back and draw a picture of this. Okay. I'm just going to draw two triangles that are congruent. So if we have two congruent triangles, and we can show that all three sides, or three corresponding sides, are congruent, then we've proven that the two triangles are congruent. So this would be S, S, S. Okay. That's let me just see if I want to add one more thing to this. No, that's going to go afterwards. Okay, so the next card, 53. If two sides and the included, underline the word included, angle of a triangle are congruent to the corresponding parts of another triangle comma, then the triangles are congruent. and this is our SAS for side, angle, side. Let's just go back to the last card and put in side, side, side next to SSS. Okay. Now on the back, let's draw a picture of this situation because it's important for us to understand the included angle. Alright? So I'm going to draw my same two triangles. I just kind of move them around a little bit each time. Okay, so if I know that, say, this side is congruent to its corresponding side, and this angle is congruent to its corresponding angle, and this side is congruent to this side, then I've proven that these two triangles are congruent. Notice how the angle is the included angle, the angle in between the two sides. Okay? Let's put under here the included angle is the angle formed by the sides being used. So if these two sides are being used, you see they form this angle. So that's the included angle. Same thing here. So this is our SAS, right? So SAS. That was card 53. So now we're on card 54. Okay. If two angles and the included side and again I'm going to underline included side of a triangle are congruent to the corresponding parts of another triangle comma, then the triangles are congruent. Okay, and this is known as ASA or angle side angle. Okay, and the included side is the side between the angles being used. That's it. So let's turn this over and check out a picture of this. So let's say that this angle, that one would be congruent to this corresponding angle. And let's say this angle is congruent to its corresponding angle. And then the included side would be the side in between the two angles being used. Okay? This is an example of angle, side, angle. Okay, let's go to 55. If two angles and the non-included side this time it's the non-included side of a triangle are congruent to the corresponding parts of another triangle then the triangles are congruent. So comma, then the triangles are congruent. And this is our AAS, or angle, angle, side. Alright, and the non-included side can be either of the two sides that are not between the two angles being used. Okay, let's see what that looks like. So here's one of my triangles. And Here's another one of my triangles. Now let's say this angle is congruent to its corresponding angle. Okay. And let's say this angle is congruent to its corresponding angle. Then we have to choose a side that's not in between. Either of the sides not in between. So let's say this side and this side are congruent. Okay, so this would be an example of angle, angle, side. Okay? Now, there's one more of these congruence possibilities or methods. That was the fourth out of 5. Okay, so let's now do the 5th one. Let me just sharpen my pencil. Alright, so that was card 55. We're on 56. Okay. If the hypotenuse and leg of a right triangle are congruent, to the corresponding parts of another right triangle, comma, the right triangles are congruent. Then the right, so comma, then the right triangles are congruent. And this is what's known as HL. And this is hypotenuse leg. Put a little arrow and put here, let me just see how I put it on the last card. This is for right. Triangles only. Now, also, either leg of the right triangle may be used as long as the corresponding legs are used. Okay, so let's see a picture of what this could look like. So now I have right triangles, all right? So I'll draw your standard, well, I'll draw it the best I can anyway. So this would be the right angle. think for a second here. This is the right angle. So we know the hypotenuse must be congruent, and then either leg that we want to choose. So let's choose the smallest one. This is HL, hypotenuse leg. Okay? So now there's another card I'd like to write quickly. This would be card 57. And I want you to say, once you prove, alright, once you use one of the 5 methods, just see something, for proving triangles are congruent. To prove 2 triangles are congruent, comma, all leftover pieces of the triangles that were not used in your method of proof once you use one of the 5 methods for proving triangles are congruent to prove 2 triangles are congruent, all leftover pieces of the triangles that were not used in your method of proof are also congruent. So one of the most important things that you can write is that corresponding parts of congruent triangles are congruent. And you can see we have a C. This is what's known as C, P, C, T, C. Alright? And we don't need to write anything else for that one yet. Alright, we're on card 58 and we're going to start talking more about triangles and angles and types of angles and things like that. Alright? First thing is an angle is the intersection of 2 rays with a common endpoint. An angle is named using 3 letters. An angle is usually named using 3 letters, where the middle letter corresponds to the vertex of the angle. Where the middle letter must be the vertex of the angle. If an angle does not share its vertex with another angle, comma, the angle may be named by the vertex letter. The angle may be named by just its vertex letter. Alright, and let's see what we mean by this. You can draw any angle. Okay, and usually they're raised, but they could be segments coming out. And this point here is the vertex. And then you can have a point up here like A, and a point over here, say C. So for the possible names, it could be angle ABC, angle CBA, or you could just say angle B because it's not being shared by another angle. Okay, but if we had another ray coming off in another direction, then it would be being shared, and then you can't do angle B because you wouldn't know which angle it was talking about. Okay? So that's card 58, little intro or little reminder about angles. Now let's talk about some more specifics about angles. Now something that's very intuitive is what's called the angle addition postulate. So the angle addition postulate says let me see. if two adjacent angles share a vertex, then the large angle is equal to the sum of the two smaller angles. And sometimes we like to write this as the whole is equal to the sum of its parts. And this is actually, don't get too crazy on this one. This is actually something that's very obvious that they put down in a theorem. And you'll see when I draw the picture what I mean. So, this is an example of what we're saying here. All right. What it says is that this big angle, right, is equal to the sum of the two smaller angles. That's all it says, which that really should be very obvious. But we do have to remember it. So let's write this down. If D, which is point D, lies in the interior of angle ABC, comma, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Right? So this small one plus this small one equals the big one. And that's it for that. Okay? That's card 59. Let's go to card 60. We're going to talk more about angles here. An acute angle is an angle whose measure is less than 90 degrees. Okay? So let's just draw a picture of this on the back. Let's say this was A, B, C, and let's say this is 40 degrees. So angle B is an acute angle. Okay? Next one. This is 61. A right angle is an angle whose measure is 90 degrees. So it is 90 degrees. Let's draw an example of that. Put a little 90-degree symbol inside that box. So let's say this was A, B, C. We could see that angle ABC is a right angle. Okay? Let's do card 62. An obtuse angle is an angle whose measure is more than 90 degrees, comma, but less than 180 degrees. So this angle is about, I don't know, let's just check real quick. Let's say this is 145 degrees. So then angle CBA is an obtuse angle. We're on card 63. A straight angle is an angle whose measure is 180 degrees. So here, angle ABC is a straight angle. Okay. Adjacent angles are two angles that share a common vertex and a common side. They do not overlap. So to see what we mean by this, it's pretty straightforward. We've kind of seen something like this before already. So we could say that angle ABC and angle CBD are adjacent angles. On the front, I'm going to put adjacent means next to. And this is card 64. So there you go for that one. Let me just see something real quick. Let's go back to card 58 for a second. And let's put an angle can also be named using a number inside the angle. And on the back, let's put a 1 in here, and we can also call this angle 1. Okay? And now let's put in parentheses, but don't confuse it with its degree measure. Okay, back to what we were doing. We just finished 64, so now we're on 65. Vertical angles are two angles whose sides form two pairs of opposite rays. also known as straight lines. Let's put they are not adjacent and are located across from one another in the corners of the X formed by the two straight lines. Vertical angles are always congruent and therefore equal in measure. Okay, let's draw a picture of this. So angle 1 and angle 3 are vertical angles, and also angle 2 and angle 4 are vertical angles. And remember, vertical angles are congruent. So this means angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Okay, this was card 65. Now we're on 66. Complementary angles are two angles that add up to 90 degrees. complements of the same angle are congruent. Also, complements of congruent angles are congruent. Yeah. Let's see. Let's draw a picture of this. There's usually two ways that you see this happening. Number one is you see it like this. Angle 1 plus angle 2 equals 90 degrees. So angle 1 and angle 2 are complements. Now the other thing is I'm just going to cut this index card. I'm not going to cut it, I'm going to draw a line halfway down the middle, and we're going to show you the other example on the other side. You could also have two angles just kind of floating around. And let's say this one is 30 degrees. And let's say this one is 60 degrees. And let's say this is A and this is B. CAD and B and E and F. So angle A plus angle B is 90 degrees. So angle A and angle B are complements. So they don't have to be adjacent, alright? They don't have to be like these are adjacent angles, but they don't have to be. They could be separate also. Okay? That's the point. That's 66. So for 67 now we're going to talk about supplementary angles. Are two angles that add up to 180 degrees. Let's see. Supplements of the same angle. are congruent, and supplements of congruent angles are congruent. Alright, and let's separate this card again down the middle. Alright. So here's one example, right? If we call this angle 1 and angle 2. Angle 1 plus angle 2 equals 180 degrees. Let me just see something. Let's add something else on this side. Adjacent supplementary angles are a linear pair and form a straight angle. Alright, and we'll talk about linear pair next. Now before we go on, let's just go back one and write down, before I forget, adjacent complementary angles form a right angle. Yeah, that's good enough. Okay. Alright, angle 1 and angle 2 are supplements. Angle 1 and angle 2 are a linear pair, and angle 1 and angle 2 form a straight angle. Now you could also have the two angles separated. Say like this. Let's say this is A, B, C, and this is D, E, F, and let's say this is 60 degrees and this is 120 degrees. we would say angle B and angle E. Actually, first we'll say angle B plus angle E equals 180. So angle B and angle E are supplements. Okay. So that's that one. And for this one, card 68, a linear pair is two adjacent angles that form a straight angle. Linear pairs are supplementary. That means they add up to 180 degrees. And if two congruent angles form a linear pair, they are right angles. So what we can say is here, angle 1 and angle 2 are a linear pair, and angle 1 plus angle 2 equals 180 degrees. And that's good enough. And that was card 68.